Glyphosate might sound familiar to you because it is the chemical in Roundup. They spray a lot of this on crops. So let's figure out how long it takes for most of it to decay. Here is my plan. Step 1, let's find the rate constant, and then step 2, let's use that rate constant in the first order rate law equation. And we know we can use the first order rate law equation because a decay process that has a half-life is generally a first order process. Also, if you saw the slides, I included that in the question. Alright, so here's the equation that relates the rate constant and half-life. And maybe you're saying, hey, where did that number come from? If I see a number in the first equation that we use, I need to know how we got there. What math did we do to get that number? And you would be right to ask that. That's good. But this is a constant. The point 693, that's ln of 2. So that's a constant value in this equation. And now we're used to seeing seconds as the unit for time. And we're used to seeing the rate constant in terms of the units of seconds. But let's just try to keep it as days here and see what happens. So there's your rate constant in the unit of 1 over days. Alright, and then here's your first order rate law equation. The trick here is not using the 0th order or the second order rate law equations, which do not apply here because this is not a 0th or second order process. And I've just subtracted ln of the initial concentration from both sides. And now let's do the trick where subtracting one natural log from another makes it turn into this. So that you can have two natural logs, one subtracted from the other, or one big natural log of one thing over the other. And pardon me, excuse me, I gotta fix this. This really belongs outside of the brackets. Okay, that's better. Alright, now let's get down to solving for t. We'll isolate it by dividing both sides of the equation by negative k. And we've got an equation for t. Now let's just plug in our numbers. And the calculator tells me 240. And I want to say days here. Let's make sure that's appropriate. 1 over days is days. And there's our answer. That's almost a year. One more note here about the signs. At this point here, I brought up this negative sign to the top, and you got to be thinking that in order to get a positive value, we're going to have negatives canceling, and that's what happens. The ln of a very small number less than 1 is negative, so you end up with a negative of a negative, which makes your answer make sense and be positive.